So, we are starting the course on operating systems. So, when we talk about operating systems, firstly we have to see what is meant by an operating system, what is the responsibility of an operating system, and what is the environment under which the operating system has to work. Okay. So, firstly let us see that what is an operating system. So, to answer this question of what is an operating system, we can say that operating system is just like a resource manager. Okay. Say for example, when we perform our day-to-day work, say somebody has rang you, you are attending a telephone call. In between, there is some other urgent work for which you have been interrupted. So, what you have to do is you have to decide that which one is more urgent, whether it is the telephone call that you are attending or it is the interruption which has been done while you are attending the telephone call. Okay. So, based on that immediate decision, you have to decide that whether to continue with the telephone call or you have to interrupt the telephone call, ask the other party to wait for some time, ring you back again, and in between you can do the other task for which you have been interrupted. Okay. So, here what you are doing is you are basically managing the time, okay, because during the same span of time you have to do more than one task. Similarly, we can say that operating system is also a manager which manages the resources of the system. Okay. So, when we say that it manages the resources of a computer system, first we have to know that what are the resources that are present in the computer system, okay, and what is meant by management of all those resources. Okay. To see that what are the resources in an operating system, now resources in a computer system, the first resource in a computer is the central processing unit of the computer, or CPU. Okay. And you all know that this is the central processing unit of a computer which performs the execution of a program operation. Okay. So, whenever the user writes a program, usually you write the program in high level language. Okay. Then the program has to be compiled, and the compiled program or the executable program has to be executed by the CPU to give you the desired result. Okay. Now, when the CPU executes a particular program, I hope all of you know that when you compile a program, the executable code is stored on the disk or hard disk of the computer. When you want to execute it, that executable code has to be brought from the hard disk to what is called a main memory in the computer system. Okay. And when the CPU executes the program must reside in the main memory. The CPU cannot directly access anything which resides on the secondary storage or hard disk, maybe magnetic tape or floppy drive or CD-ROM, whatever it is, all those are secondary storage devices. And CPU does not have any direct access on the secondary storage device. Right. So, whenever a program is to be executed, the program must be brought from the secondary storage to the main memory, so that it can be accessed by the CPU for execution. Not only the program, even the data which is to be processed has to be brought from secondary storage to main memory in order that the CPU can access the data. Okay. So, anything which is to be accessed by the CPU must reside in the main memory, it cannot reside in any of the secondary storage. Okay. So, the first and foremost resource in a computer system is the CPU. Okay. Now, in the earlier systems like DOS based computer system, those were strictly single user or single programming system. In a DOS machine, it was not possible to execute more than one program at a time. Whereas, on the other hand, your Unix-based machines, you all know that Unix-based machines are used as servers, in the sense that more than one persons can work on a Unix-based machine simultaneously. Okay. Now, when I say simultaneously, whether at the same time instant more than one user program can be executed or not, we'll come to that later. But as an user, when I work on a machine, it appears that the machine is giving me all the time, though practically it does not happen so. It gives me only part of the entire duration of time. Okay. So, when we talk about managing this resource that is CPU, we have to think that if you have more than one user working on a machine simultaneously, in that case, how this CPU has to be shared among all those users. Okay. So, that is one resource, that is the central processing unit, and the responsibility of the operating system is to manage this central processing unit. Okay. The second resource in a computer system is the memory, or to be more specific, it is the main memory. Okay. Again, as I said, that whenever a program or any piece of data is to be accessed by the CPU, that program as well as that piece of data must reside in the main memory, right? So, if we have a multi-user or a multi-programming system, okay, where we say that more than one user program is to be executed simultaneously, so obviously more than one user program or parts of more than one user programs as well as the corresponding data units on which the programs has to be executed, they also should reside in the main memory simultaneously. But in a computer system, we have a single memory block. When I say block, it does not mean that it's a single memory chip. There can be multiple memory chips to make a single memory block. Okay. So, I have a single main memory block in the computer system which has to be shared by more than one user programs working on the computer system simultaneously. Okay. So, again the question of management comes, because I have a single memory block which is to be shared by more than one users or user programs. So, how to manage this sharing of a single memory block by more than one user programs? Okay. So, that is again a responsibility of the operating system. Okay. Then the third category of resource that is present in a computer system is the secondary storage. This secondary storage consists of the hard disk that is present in the computer. It consists of the magnetic tape that is also present in some of the computers. It also consists of the floppy drive, the floppy disk. It also consists of your CD-ROM drive or the CD-ROM. All of them come under the category of secondary storage. Okay. Now, though the main memory as well as secondary storage, both of them are some kind of memory, but we put them under separate category because the way in which the main memory is accessed and the way in which the secondary memory is accessed, they are different. Not only that, in the secondary storage, when I have different types of secondary storage, I have hard disk, I can have floppy drive, I can have magnetic tape, I can have CD-ROM. The characteristics of all these secondary storage are also different. They don't have uniform characteristics. So, accordingly, the way in which these different secondary storage devices are to be accessed, they are also different. Okay. So, main memory, which is accessed directly by the CPU, and we have said that the secondary storage cannot be accessed directly by the CPU. So, whenever the CPU finds that it needs a piece of program to be executed next, or it needs a piece of data which is to be processed next. Okay. If it finds that the required instruction or the required program or the required data, they are not present in the main memory, it has to instruct another unit which usually we call as device driver. It has to instruct the device driver that such and such data units or such and such program units are present in the are not present in the main memory, which is required. So now it will be the responsibility of the device driver to look for that piece of information. It may be instructions or it may be data from the device or the secondary storage device and pass it to the main memory so that it can be accessed by the CPU. Okay. So, you find that the way the main memory is accessed directly by the CPU and the way the secondary storage is accessed, they are different. So, when we discuss about the memory management, though both of them comes under the category of memory, we will discuss them separately. Main memory will be one type of access mechanism. Secondary storage will have some other kind of access mechanism. Okay. So, in addition to these resources, that is CPU, main memory, secondary storage, we also have another very fundamental kind of resource in a computer system, which are called input output devices. Or in short, they are popularly known as IO device. So, what are these input output devices? These are the devices through which an user will feed his data, an user will write a program, that is anything to be inputted to the computer system, the device which is used for that is an input device. Okay. So, typically or normally what you use when you work on a computer, that is a keyboard. Through a keyboard, you either feed the data or you write an instruction, you give some command. Okay. So, all these things are done through the keyboard. So, keyboard is an input device, right. Similarly, when you want to get something from the computer, you get it in the printed form. For that, what you use is a printer. So, printer is an output device. Similarly, if you want to have some visual outputs online, you make use of the video terminal. So, video terminal is also an output device. Okay. Now, considering the nature of these input output operations, you find that this secondary storage can also be considered as input output device. Okay. Because usually what we do is, whenever a data file is to be processed, the data is normally residing on the secondary storage. When you execute the program, some instructions within the program, they open the data file, read the data from that file, and after the reading is complete, it closes the file. That means it is also inputting the data, but in this case not through the keyboard, but it is inputting the data from the secondary storage or hard disk. So, in that sense, hard disk is also an input device, right. Similarly, when you process a data, how often we make use of the printer? Very rare. When you just want the final printout to be included in some report, we make use of the printer. But otherwise, what we normally do is, all the outputs that we get, we usually store it on the secondary storage in the form of a file. That is a processed data file or output data file. Okay. So considering that, the secondary storage or the hard disk can also be considered as an output device. Right? So when we talk about this I/O devices, along with that, this secondary storage will also be considered. We'll consider the secondary storage as some special kind of input output devices. Okay. So usually these are the four kinds of resources which are present in a computer system. One is CPU, then you have the main memory, then you have secondary storage as a special kind of input output device. We have other normal input output devices like keyboards, video terminal, printer, these things. Okay. So the responsibility of the operating system will be to manage all these resources in an efficient manner so that more than one users, in computer terminology, you can say that more than one clients, they can make use of these resources simultaneously to get their work done in as efficient as possible manner. Okay. So the major responsibility of the operating system will be to manage these resources. Now, whenever we talk about all these resources are confined in a single system. But you also have to think whether the modern operating system can be satisfied, can remain satisfied with a single computer system in isolation or not. Because as you know, that with the advancement of computer networking, with the advancement of information distribution, we cannot remain satisfied with a single computer. Okay. So now we have to think of that if I have multiple computers which may be distributed in different geographical locations. Okay. But what I have is a network interconnecting all these computers which are distributed in different geographical places. Right? So I have different isolated computer systems. Each of those computer systems are full-fledged computer. I mean, they are independent computers. So each of them will have all these four kinds of resources. So even if the network fails, the computer can work in isolation. Okay. So I have these different independent computers and a network interconnecting all these computers so that you can transfer the information from one computer to another computer, from that to somewhere else. Okay. So really we have to think of a distributed environment where the information, required information, can be distributed in different places. Okay. So I have to think of a distributed computing system. Right. So when I talk about this distributed computing system, we have isolated computers consisting of, let us put in the form of a block diagram, so CPU, with that I have main memory, I have secondary storage, and I also have input output devices. So this is a single computer system. Right? And I can consider a case where I have a number of such computer systems which are put in different geographical locations, and what I have is an internetwork a network interconnecting all these computer systems. Okay. Now, the aim of having sorry, the aim of having such a distributed computing environment is that now it is not necessary that all the information has to be put on a single computer, because in that case your storage requirement may be tremendous. So, to take care of that, what I can do is, if I have huge amount of information, it's a very large database which has to be put on a single computer. Now, what I can do is, I can break this database into a number of pieces, the data into a number of pieces, and different pieces can be stored on different computers. But still, sitting on a particular terminal, sitting on a particular computer, if I want to access all these information, that is also possible, because all these computers are networked. So, I can go via the network and access any information that I like pertaining to that particular database. Okay. Secondly, having such a distributed computing environment can avoid duplication. To assume a case that I have a number of computers in different geographical locations, and all the computers have to be identical. That means the nature of work which has to be performed on all these computers, they are same. So, coming to that database application again, if it is the same database which is to be used, then on say this computer 1, I have one database. If I do not have this inter-network, on this second computer, I also want to have the same database. In that case, what I have to do? I have to put the same piece of data on this, also on this. That means I have to go for data duplication or information duplication, which is not really needed. When your computer networking is becoming more and more efficient, I can have the information in one place and access it from some other place. Okay? So, effectively that means efficient utilization of resources. Now, having such a type of distributed environment, I need not have similar copies or similar resources in all the places. At different places, I can have different resources and share them via the network. Okay. So, in today's operating system, the operating system cannot really be confined to an isolated system like this or this. Okay. The modern operating system has to cater the need of such a distributed computing environment. Okay. Again, here we have to think that how to manage all these resources in the distributed environment efficiently, which becomes the responsibility of the operating system, right? So, in brief, we have seen that an operating system can be considered as a resource manager whose major responsibility is to manage the resources in such a way that all the clients of that computer system can make use of those resources in efficient manner. Okay. So, that will be the responsibility of the operating system, and this is the thing that we do in our day-to-day life. This is nothing great about the operating system. Operating system is not doing any great job. It is doing the same thing which we do in our day-to-day life. But we being more intelligent, having our own intelligence, we can take quick decision what to do and what not to do. Okay. But operating system being a program, it is nothing but a program. It is a program which is also executed by the machine. And obviously, the machines, however powerful they are never more powerful than human brain. Okay. So, we have to try to impart similar kind of power to the operating system, so that it can also take quick decision. and more logical decision. That is what the operating system designers have to do and translate them into a code so that it can be executed on a computer. Okay? So, that is what is meant by operating system design. Okay. So, with this I briefly introduced what is meant by operating system and what are the responsibilities of the operating system. Okay. Now, let me come to the first aspect or the first responsibility of the operating system, that is the CPU management. Or sometimes this is also referred to as process management. Okay. Now, before I start, let me tell you what is a process, because in many cases we will be using program, process, user, these terms will be used interchangeably. So, a process is, you can say, that a program in execution. Whenever you execute a program, that becomes a process. Okay. A program can reside on the secondary storage, which is not active. It is not making use of any CPU time. So, it is just a program. It has not become a process. When the program starts execution, then we call it a process. Okay. A process does not mean a separate CPU. If we have two or more processes running in the system, that does not mean that the computer system has two or more CPU. Even with a single CPU, activation of more than one process simultaneously is possible. Okay. So, let us see what is meant by this process management. Okay. Yeah. So, as we said that the responsibility of the operating system is to manage the resources, CPU being one of the resource, is to manage this CPU so that it can be shared by more than one process simultaneously. Okay. How that can be done? Now, before going to simultaneous access, let us see that what we will look for in CPU management. Okay. So, you see that I being a user, I initiate a program to be executed by the CPU, and after initiation, what will be my demand? My demand will be that the program should be completed as early as possible, or at least the CPU should start execution of my program as early as possible. Okay. So, there are two terms which are commonly used. One term is called waiting time, and the second term is called turnaround time. Okay. So, what is the waiting time? If I submit a job, submit a program for execution at say time instant t0, okay, and the CPU starts execution of my job which I have submitted at time instant t0 at some time instant say ti. Okay. So, t0 is the time instant when I have submitted the job for execution, okay, and the CPU being used by many other users. It is not guaranteed that whenever I submitted the job, the CPU will immediately start executing it. It cannot be expected. because that time maybe the CPU was busy for execution of some other user program. Okay. So, I have submitted the job at time instant Ti, and the CPU starts executing the job at time, sorry, I submitted the job at time instant T0, and the CPU starts execution of the job at time instant Ti. Okay. So, how much time I am waiting? That is Ti minus T0. So, this Ti minus T0 is the time which is known as waiting time. Okay. So, at time instant Ti, the CPU starts execution of my program. Okay. It will take some time to complete execution, and after completion of the execution, the CPU will give me the output. Okay. So, maybe at time say T P, the CPU gives me the output. Okay. So, I have submitted the job at time instant T0, I get the output at time instant Tp. So, this Tp minus T0 is called the turnaround time. That is the time duration between completion of the job and the time instant at which the job has been submitted. So, this total duration T0 to Tp is called the time turnaround time, whereas the duration from T0 to Ti, that is called the waiting time. Okay. So, as an user, when I have submitted a job, obviously my demand will be that the waiting time should be minimum, because I am not ready to wait, I am very busy. I want that the moment I give the job, I should immediately get the output. Practically that is not possible. Okay. So, my requirement will be that the waiting time should be minimum, at the same time the turnaround time should also be minimum. Okay. So, let us consider this waiting time business. My requirement is that the waiting time should be minimum, in spite of the fact that the CPU is being used by many other programs. Okay. So, let us consider a situation that we have a number of jobs, say job called J1, a job of J2, a job of J3, a job of J4. So, these are the 4 jobs that I have in the system. Okay. So, job J1 takes a time of, let us say, 15 time units for execution. Job J2 takes a time, let us say, 8 time units for execution. Job J3 takes a time, let us say, 10 units of execution. Job J4 may take a time of 3 units for execution. So, these are the 4 jobs and these are the corresponding execution times. Okay. If I assume that this is the sequence in which the jobs have arrived to the system. Okay. Later on, I will come to the corresponding technical terms which are used for this. But let us, for the time being, consider a simple situation that I have these 4 jobs J1 to J4 and the corresponding execution times of this. Okay. And I also assume that the jobs have arrived in the system in this sequence, J1 first, J2 second, J3 next, J4 the last one. Okay. Usually the type of scheduling means deciding in which order these jobs are to be executed. So, usually the scheduling will be what is called first come first served. That is because job J1 has arrived first, I have to execute it first. The next job to be executed is job J2, next job that is to be executed J3, the next job is J4, because they have arrived in that particular sequence. Okay. So, typically my execution sequence will be J1, which will take 15 units of time. Okay. Then I have to execute J2, which will take 8 units of time. Then I have to execute J3, which will take 10 units of time. Then I have to execute J4, which will take 3 units of execution time. Okay. So, because I have a single CPU, I cannot execute more than one job simultaneously, that is, I cannot initiate J1, J2, J3, J4 at the same time. First J1 has to be executed, followed by J2, then J3, then J4. This will be my sequence of execution, right. Now, here if I say that I start accounting at this position, that is when J1 has started execution. Okay. And mind you that the time that I am considering now is the waiting time. I want to find out that what is the average waiting time if I go for fast come fast serve type of scheduling. Okay. So, here you find that because I am starting accounting here, the waiting time of job J1, okay. So, waiting time of job J1, that is equal to 0, okay. Waiting time of job J2 is 15, waiting time of job J3, that is 23, and waiting time of job J4, that is 33, right. If you add them up, how much you get? 71 time units is the total waiting time. And what is the average waiting time? This divided by 4, how much is that? How much? 17.75. This is the average waiting time for these 4 jobs. Okay. Now, if I just change this order, so this is the kind of scheduling that which has been used, is called first come first serve, that is FCFS scheduling. That is, the jobs are executed in the order in which they have arrived. Okay. Now, if I just change this sequence, what I will do is let the jobs arrive in the order in which they comes, because I do not have any control over them, because the jobs will be arrived depending upon the way or the order in which different users they initiate their programs. Okay. But what I have control is in the way in which the jobs will be really executed by the CPU. Okay. So, what I can do is, whenever the jobs are arriving, I put them in some sort of queue, then from the queue I decide that which job is to be executed next, or which job is to be picked up and given to the CPU for execution. Okay. Now, considering this same queue of jobs J1, J2, J3 and J4, I reschedule the jobs. That is, first I execute job J4, which takes 3 units of time, right. Then I execute job J2, which takes 8 units of time. So, this takes 3, this takes 8. Then I execute job J3, which takes, let us say, 10 units of time, considering the same sequence, same set of jobs. Then I execute job J1, that takes 15 units of time. Okay. Now, with this scheduling, if I compute what is the average waiting time, you find that waiting time of job J1 is equal to, sorry, job J4, because that has been executed first. Waiting time of job J4 is equal to 0. Waiting time of job J2 is equal to 3 time units. Waiting time of job J3 is equal to 11 time units, and waiting time of job J4, that is how much? Sorry, J1. Yeah, waiting time of job J1 is 21 time units. What is the total now? 35 time units, and average waiting time in this case, that is 8.75 time units. So, you find that just by changing the order, in the first case we have taken the simplest approach, that is first come first served type of scheduling, that is the job which has arrived first has been served first, the job that has arrived last has been served last. Okay. So, going by that simplest kind of scheduling, our average time, waiting time was 17.75 time units. On the same jobs, if I simply change the schedule, that is the order in which the jobs are to be executed, I simply change that and I get an average time, waiting time of 8.75 time units. Okay. So, you find that the average waiting time has been reduced drastically. Okay. So, naturally an user will prefer the second kind of scheduling over the first kind of scheduling, because the first kind of scheduling gives more average waiting time, whereas the second kind of scheduling gives less average waiting time. Okay. So, it is not that the user will prefer. The user will prefer in the first case the situation like J1 where the waiting time is 0, in the second case the situation of J4 where the waiting time is also 0. That is what the user will demand, but that cannot be met by the system. So, the system has to go by some optimization. Okay. So, the system in this optimization has to try to minimize the average waiting time. Okay. So, considering that, we have to consider the second case of scheduling and not the first case of scheduling. So, you might have noticed one thing in the second kind of scheduling, that the job which has been selected for execution first, that is the job which takes minimum time. Okay. And the job which has been selected for execution last, that is the job which takes longest time. Okay. So, the approach is that all the shorter jobs you try to execute first, because the waiting time of a job depends upon how much time the jobs which are executed before that are taking. Okay. So, if I execute a shorter job first, the waiting time of the next job is reduced. Okay. So, that is why in this second case of scheduling, where I am executing the shorter jobs first, the average waiting time is reduced. Okay. And this is a kind of scheduling which is called shortest job first, SJF kind of scheduling. Okay. So, our first case of scheduling, the first type of scheduling is the first come first served scheduling, or FCFS, and the second kind of scheduling is the shortest job first kind of scheduling, that is SJF. Okay. So, this is just an introduction to tell you what should be our objective when we try to manage the resources. In this case, our objective was to minimize the waiting time. Okay. Similarly, there are various such objectives which are to be met, and that we'll see later on as we go through this course. So